The sky just lit up. A star has exploded in our own galaxy, the Milky Way. Scientists are absolutely shocked. This was not just any flash in the cosmic pan. It was an event so unusual, so unexpected. It is rewriting what we thought we knew about the lives and deaths of stars. Imagine looking up at the familiar, quiet night sky. A canvas of tiny, twinkling lights, the same for generations. Then, suddenly, one of those lights flares up with impossible brightness, sending a powerful message across thousands of light years. This is what astronomers have just witnessed, a truly explosive discovery. Not a quiet fading away like an old lamp dimming. A grand, dramatic spectacle. A massive star, many times larger than our sun, has ended its life in a way that defies understanding. For a brief, brilliant moment, it shone with the light of millions of suns. The blast sent ripples through space. Scientists worldwide turned their most powerful telescopes to the new point of light. They hoped to see a familiar pattern. Instead, they found a complete surprise. This star did not follow the rules. Its behavior was strange. This is, really something. To understand why this explosion is so special, let us first talk about stars themselves. What is a star? In simple words, a star is a giant glowing ball of hot gas. Think of it like a huge cosmic furnace. The main fuel for this furnace is a gas called hydrogen. Stars are born inside vast cold clouds, gas, dust. Gravity, the same force that keeps our feet on the ground, pulls this gas and dust together into a tight, spinning ball. As this ball gets denser, the pressure and temperature at its core rise to incredible levels, millions of degrees hot. This intense heat and pressure trigger nuclear fusion. This is the star's engine. Tiny hydrogen atoms are smashed together. They fuse to become helium. This releases a tremendous amount of energy as light and heat. The outward push of energy balances the inward pull of gravity. This keeps a star stable for billions of years. Our sun is in this steady phase, burning hydrogen. Just like people, stars have a life cycle. Born, live, and then die. The lifespan of a star depends on its mass. Smaller stars are very fuel efficient. They can live about 10 billion years. In contrast, massive stars, 10, 20, even 50 times bigger, are the rock stars of the universe. They are incredibly bright and hot, but they live fast and die young, burning fuel at a furious rate, like a small efficient car versus a giant truck. And it is the death of one of these giants that has now captured our attention. So, what happens when a massive star runs out of fuel? Its end is not quiet. It is the most powerful explosion in the universe, a supernova. After hydrogen becomes helium, the core starts fusing heavier elements, carbon, oxygen. This continues all the way up to iron. But fusing iron consumes energy. The furnace suddenly shuts down. The balance breaks. Without outward pressure, gravity wins. The core collapses in a fraction of a second, at terrifying speeds. The core is squeezed into an incredibly dense object, maybe a neutron star or even a black hole. The outer layers crash in and bounce, launching a gigantic shockwave. This is the supernova explosion. For weeks or months, a single supernova can outshine its entire galaxy of hundreds of billions of stars. If one were as close as our nearest star, it would rival the full moon, visible by day. The star's outer layers are flung into space at incredible speeds. The expanding cloud is a supernova remnant, glowing for thousands of years. These explosions forge and spread heavy elements, the oxygen we breathe, the carbon in our bodies, the calcium in our bones, the iron in our blood. Forged in stellar hearts, scattered by supernovae, the galaxy's great distribution system. They seed new stars, new planets, and eventually, life itself. Every atom in you, heavier than hydrogen, once belonged to a star that exploded. Pretty wild. Now let us return to the main story. In a quiet corner of our Milky Way, A star casually monitored for years suddenly began to act very strangely. This was not a star known for its drama, a massive blue giant. It was supposed to have millions of years left before its finale. Then, the alerts started coming in. Telescopes detected a sudden, rapid brightening. It flared with an intensity that took everyone by surprise. It was as if a sleeping giant had suddenly woken up, and it was not happy. Powerful bursts preceded the main event. Over months it violently shed outer layers, throwing massive shells of gas into space. Not a gentle stellar wind, more like convulsions tearing it apart. Far more powerful than standard theories predict, a new kind of death throw. It's like a movie you think you know, then the ending flips, explained Dr. Kenji Tanaka. The final explosion was peculiar, incredibly bright, but with a very unusual chemical signature. Spectra act like barcodes of elements, and this barcode did not match the usual patterns. The blast interacted with the earlier shells, creating a unique, puzzling light show. This star did not follow the script, forcing astronomers back to the drawing board. Catching it required a global effort and an arsenal of tools. Automated surveys raised the first alarm. Instruments worldwide raced to gather data. Fast, collaborative, global. Across the spectrum. X-ray to radio, each giving a piece of the puzzle. Even elusive neutrinos were caught, like seeing lightning and hearing thunder. Past and present data combined to trace the star's strange lead-up. Piece by piece, the unusual death is revealed. This discovery is much more than a beautiful firework. It challenges and improves our models of stellar evolution. When an event does not fit the model, it is a gift. Our understanding is incomplete. Pre-explosion outbursts hint at deep processes, perhaps rapid rotation or powerful magnetic fields. Supernovae make heavy elements, but in what ratios? This strange blast may have mixed and spread them differently. That shapes where planets, and potentially life, can flourish. It gives a local analog to distant mysteries we cannot resolve in detail. Now we can study the progenitor and watch the remnant evolve in real time. When we look up, we feel small. Yet events like this reveal our profound connection to the cosmos. The story of this exploding star is also our story. The iron in our blood, the calcium in our bones, the oxygen we breathe, all stardust. Think of the Milky Way as a giant cosmic kitchen, cooking elements over billions of years. Each supernova opens the oven, releasing newly baked ingredients. Our solar system formed from recycled star material. Reading the remnant's light is like reading a recipe. Which elements and how much? By studying supernovae, we study our own origins, our cosmic ancestry. So when you look at your hand, remember, its atoms were forged in stars. We are intimately connected to the cosmos. We are stardust, literally. This discovery is another chapter in how the universe creates the possibility of us. This discovery answered some questions and opened a Pandora's box of new ones. The biggest question is, why did this star behave so differently? One idea, a hidden companion stripping outer layers, triggering violent eruptions. But there is no direct evidence yet. Another idea, extreme spin or magnetic fields causing instability and mass loss. We will need more data and better models. As the remnant expands and cools, its changing light will reveal new clues. Infrared views may expose lingering heat from a companion or map newly formed dust. Next-gen ground telescopes will sharpen images and spectra. Observation and theory will dance together for decades. In the end, this explosive discovery reminds us of wonder and our place within it. For millennia, the stars have been our guides, our calendars, our myths. Today we read them with physics and chemistry. This exploding star is telling a new story, and we are here to listen. Even in our own galaxy, there are processes we do not yet understand. The age of discovery is not over. Every new telescope and survey promises surprises. Keep looking up, support the quest, celebrate discovery. Studying stars connects us to origins, fuels technology, and inspires curiosity. Cooperation made this possible, a model for challenges on Earth. Let this new light be an inspiration. We are a way for the universe to know itself.